This is JavaScript, HTML, matrix.
Okay. Energy now.
Yep. And then we store the difference between energy now and energy previous. Store that step diff. And then we've got this other logic here, which this is for finding the cardinal directions, and then we color code that on this. Another little convenient or nice looking thing that I did, I also added this. So rather than snapping to the cardinal directions, it's a more continuous thing, which looks kind of interesting.
What are these black dots? Because I'm seeing the black dots propagate on the edges.
Those are, that's just zero. The average vector is null. So it's not pointing up or down or left or right. It's just sort of pointing at itself.
So that is the highest local amplitude?
Yes.
That's what you can think of as being a photon or an electron. That's like the peak of the wave. Oh, so if you go back to that, what was that black and white?
This is the difference buffer. That's this energy now minus energy previous.
So it's not completely diffusing. Here's something else about what could be improved for this simulation. Normalizing it would be perhaps required for this to be as accurate as possible.
Yeah, just so that we're not going into the floating point limits as far as precision goes.
Correct. So you can think of it like, why doesn't a particle just disappear? Why doesn't it completely diffuse? You would think if it's just averaging, it should completely diffuse. But if you're thinking of the universe as normalizing, it's relative. You know, words are kind of blunt tools, but I'm going to try and explain this as well as possible.
Right.
If you're thinking of the universe as being a relativistic system, where everything is just related to everything else, every other cell is zero. Okay, you plop an amplitude of 1 down there, and now that 1 is dividing infinitely by its local space-time density. It would never totally diffuse. It would keep on dividing, so it would keep on dividing itself. However, because you can never divide down to 0, no matter how many times you divide that value of 1 by whatever level of precision you want for this, no matter how many times you divide it by any other value, it would never divide down to 0. Furthermore, the value would always be greater than its division. So that would create particles that are persistent. They would never fully diffuse. They would be persistent.